So for, starting on the side that says 3a, so with your square roots, for number 1, the negative square root of 150 can be broken down to 25 and 6 if we're doing the shorter method, finding the highest perfect square that goes into these two, or this square root of 25 is 5, so our final answer would be negative 5 times the square root of 6. Questions on that one? For number 2, same thing. 196 is a perfect square. So if you didn't see that, and let's say you took 49 and 4, 49 and 4 are both perfect squares, and you would get 7 and 2. You would need to multiply 7 and 2 together to get 14. Either way, you would still get 14. And then, yes.
Why do we have that extra xz at the end?
2 goes into 3 once with 1 left over. 2 goes into 4 twice with nothing left over. 2 goes into 9 4 times with 1 left over. So everything on the outside would come to the front. 14xy squared z to the 4th. Everything underneath the square root would stay inside, so xz. Did that answer your question, Susan?
Kind of?
Because we divided it by 2 and that was what was left over. Yeah. Any other questions on this one? Number 3. So I'm going to talk through this, and then there's a piece that's kind of new information. But as we start to simplify this, I don't know what this person did, but it was incorrect. As you start to simplify 162, you can break it down to 81 and 2. So that would be 9 times the square root of 2. Maybe they took the square root of 9 again, and that's how they got the 3, but then they didn't multiply it by the negative 4. I don't know. They did something wrong there. So we need to, I'll come back to that. 2 goes into 3 once with 1 left over. 2 goes into 2 once with nothing left over. So on the outside, we have the negative 4 that was already there, the 9 that we simplified, the a that we simplified, the a to the 5th that was already there, and the b that we simplified. On the inside, we have the 2 and the a. And then we need to combine all of this. So multiplying the numbers, we get negative 36. So if you combine these two, just like when we separate, this became a times the square root of a. This, if we combine them back, we have a to the 6th. And we'll talk more about that when we get into our next unit, so it's okay if that didn't make a whole lot of sense. Times b times the square root of 2. Okay?
Still lost and I've got 6.
We added the exponents. That'll make more sense in our next unit.
Why didn't we multiply it by 2
Multiply
like
by
you
2.
did in 15?
Multiply what by 2?
You multiplied the 7 by 2 in number 2. Why not?
So I didn't actually do that. I was saying if you broke it down to 49 and 4, which would have got you 7 and 2. 196 is a perfect square. That's why you would have multiplied them. There is no 2 on the outside. 2 on the inside.
Oh.
Priscilla.
Number 3, like when you're adding everything together. Where's that one?
This part.
The other middle one. That's right.
This part.
That's right underneath the
This part. So we brought this out. We split this into 81 and 2. Square root of 81 is 9. 2 goes into 3 once with 1 left over. 2 goes into 2 once with nothing left over.
That's one. I forgot.
Any other questions on 30? On the back. For number 1, you need to first bring out your -1 so that you could just deal with the positive. The highest perfect cubes that you could divide out of these were 64 and 2. 64 you can take the cube root of and get 4. And your final answer was -4 times the cube root of 2. I'm using parentheses so we don't get confused and think 3 is an exponent of 4 and not with the root. You don't have to use parentheses. You can if it helps you feel better. Questions on 1? Number 2. The highest perfect cube that goes into 432 is 216. 216 and 2. Take the cube root of 216, you get 6. 6 times the cube root of 2 would be your final answer there. Questions on that one? Then for the last one, if you just started to simplify this, the highest perfect cube that goes into 1944 is 216 and 9. 9 is not a perfect cube, it is a perfect square, but we can't break it down more. So this would be 6 times the cube root of 9. You could also say that this is not fully simplified because you could break this down to the cube root of 8 and the cube root of 9, which would have gotten you 3 times 2 times the cube root of 9, so still 6. Either way, it was not fully simplified. Do we have any questions on 3? Everyone should have notes that look like these. Make sure those are out in front of you. For those of you that did point 1, this is the answer to that. -14 y to the third times z times the cube root of 6xz squared. If you didn't get that or didn't start that one, you can write that answer and then go back and simplify that later.
Wait, are these today's notes?
This is from last time. So if you finish the quick text first, I said go back and do this problem. I'll pull this back up later. If you need that answer again. Okay. So now we're going to be talking about radical operations, adding, subtracting, multiplying radicals. So when we add or subtract radicals, we need to keep these rules in mind. 1, we have to simplify all the radicals. So all the stuff we were doing last class and the class before that is still in play. We also have to make sure that they are the same index. So we cannot add a cube root and a square root together. They have to be both square roots or both cube roots. Then we also have to make sure they have the same radicand. So the number underneath the square root. If that's not the same, we can't add or subtract them together. So think about that like terms. The only way we combine these like terms is if they have the same number underneath the square root. Once we simplify and determine if they have the same or not, then if they do have the same, we can add or subtract just the number on the outside, the coefficient of the radical, and the radical itself would stay the same. So think about that like terms when we add 3x and 5x, we're really just adding 3 and 5 and adding x next to it. Same thing here. We would take the numbers in front, add those together, and keep the radical the same. Okay, so let's do a few of these. Starting with this example. Right now, these are both square roots. Do they have the same radicand?
No.
No. So we can't add them as is. Can we simplify either one of these?
Yes.
Yes, the 20. We're doing shortest method. What is the highest perfect square we can divide out of 20? 4. Square root of 4 is 2. And we're going to bring down the negative 2 that was in front. And then we're also going to bring down this last term. So then we can multiply this part. So negative 4 times the square root of 5 minus 2 times the square root of 5. Now do they have the same radicand? Yes. So now we can subtract them together. So we're taking negative 4 minus 2 and multiplying it to the square root of 5. What would our final answer be? Negative 6 times the square root of 5. Even though we are doing operations, it's still good practice to put both in your calculator, double check to make sure these work. So put this original example in your calculator, and then put this in your calculator and make sure those decimals are the same. Make sure you're putting minus for the one in the middle, but negative for the first one. So negative 2 times the square root of 20 minus 2 times the square root of 5. Savannah. Yes. Did they match? Let's move forward. Number 1. These are both square roots. Do they have the same radicand? Can we simplify these anymore? To what? To what? 3 and 2. Are either of those perfect squares? 2 times 2 is a perfect square, but not 2 by itself. So we cannot break this down any further. We wouldn't have a pair of numbers, so that's going to stay square root of 6. So we can take 3 minus 2 times the square root of 6. This would be 1. Or just the square root of 6. Questions on this so far? We're going to skip on to number 3. You can't add these as is. Which of these could be simplified? 63. What is the highest perfect square we could divide this by?
40.
Double check that here.
9.
9 and
Minus 7.
times 7. So this would give us 3 times the square root of 7. We would bring down our plus 2. And also bring down our 10 times the square root of 7. So the big thing with this is making sure you bring down everything, because if you forget to bring down something, your answer is going to change. No, it's plus 2. So then simplifying, we have 10 times the square root of 7 plus 6 times the square root of 7. And then 16 times the square root of 7.
Wait. How did they?
We got 3 because the square root of 9. Then we brought down this 2.
Wait. So why did you bring out? Wait. How did we? Why did you bring out a 2?
Because there's
We have to. You can't just leave this by itself. So whatever was in the original, we have to bring that down. Fellas.
So is it always going to be, is it always going to equal the other side, not just the other side, is it always going to be?
No. Sometimes you will have different radicands and you cannot add them together.
So you would.
No, you would just put it as the most simplified version. So let's say you got 2 different things and it was 3 times the square root of 2 plus 4 times the square root of 3. Can't add them together, but that's his simplest form. We would just leave it like that. Okay, let's try number 6. Now we have 2 things we need to simplify, so take it one step at a time. What is the highest number we can divide out of, highest perfect square we can divide out of 28? 4 and 7. Square root of 4 is 2. And we have to bring down our negative 4. We also have to bring down our positive 4. And simplify 112. That looks like a 9, not a 4. What is the highest perfect square we can divide out of 112?
100.
49 and what? Square root of 49 is 7 times the square root of 3. So this would be an example. So then we can multiply everything together. Negative 8 times the square root of 7 plus 28 times the square root of 3. We cannot combine those, but because we simplified both of them, put the original in your calculator and then this in your calculator and see if the decimals match.
It's 49. Yeah, it is.
Okay,
Yeah.
what was this supposed to be?
It's, I think it's 16 and
16 and 7? Okay, don't guess. I'm also not checking you guys' work. Whatever you say, I'm taking verbatim. So 16 and 7 would be 4 and 7, which would make this 16 and 7. So then you could simplify, and what would that be?
8.
8 times the square root of 7. Still double check that to make sure that the decimals are the same. Were they the same? Or 7 and 8. Do we want to see 7 or 8 or move on to the next page? Anyone need or want to see 7 or 8? Which one were you going to say? You guys agree. So we'll do 7 and then we'll move on. I'm sorry. You can move on.
Oh,
Okay, 4, 7. What is the highest perfect square we can divide out of 160? 15 and 10. So that would be 4 times the square root of 10. I'm going to bring down this negative 4. What is the highest perfect square we can divide out of 90? 9 and what?
no, I was wrong.
No, you
I was
are.
thinking of 2.
9 and what?
Earlier than that.
9 and 10. So that would be 3. Okay, this is not for this last.
So it doesn't matter if it's 2.
What do you mean by that?
Like you can do square root of 12.
We're not taking the cube root. We're taking the square root of 9. It just happens to be 3. So this 3 is not cube root, it's the square root of 9. Negative 16 times the square root of 10 minus 6 times the square root of 10. What would our simplified answer be? Negative 22 times the square root of 10. Okay, move on to the next page. Alright, and then we're going to do a few of these. So, starting with number 9, now we have 3 of these. We first need to see, can we simplify any of these? No. Square root of 6 is as far as we can go. Square root of 10 is as far as we can go. So now we have to see which ones we could add or subtract together. Square root of 10. So if we combine those two, what would that be? And then we would bring the other one down. The order here doesn't really matter. If you want to put the lowest square root first, that's fine, but it doesn't matter. As long as whatever the sign is, you make sure it does follow. So if this was positive and you switch them, as long as you keep this positive and this negative, you're good.
That's it.
Yes.
0.
So
So we don't do anything that negative or
put this in your calculator, this one, and then put this in your calculator, make sure the decimals are the same. Did we
I
get
think it's different.
We have to put them all. Put the entire thing in at the same time. And then put this thing in all at the same time. So then
Is it gonna be a minus or negative?
negative, minus, minus. The first one is a negative, the others are minus.
Wait, how do I do square root?
It's I'll put second. No. Second and then the square root. Second and the
X
square root.
squared. They should be the same.
You know, when you're like, oh, this shows like that's
I'll put this in real fast just so we're all on the same page. Negative 2 times the square root of 10 minus 3 times the square root of 6. Sorry, I forgot what the other one was. Minus 2 times the square root of 10. Negative 4 times the square root of 10 minus 3 times the square root of 6. Should be the same.
So it's supposed to look like that. Okay.
Should be the same. Okay, let's do number 12. 12 now has radicals that we have to simplify for each one. So again, take your time with each one. What is the highest perfect square we can divide out of 8? 4. 4. And then 2 would be the other one. So this would be 2 times the square root of 2 with the 2 that was already out front. What is the highest perfect square we can divide out of 96? 16. 16 and what? 6. Okay. 16 and 6. That would be 4 times the square root of 6. Then we have a negative we need to break down.
When you got from the point, you can break it down from that was back to 96.
This one?
Yeah. That's what we got down.
Yes. What is the highest?
Negative or minus?
They're the same thing, but minus.
They are.
What is the highest perfect square we can divide out of 24? 4. And 6, that would become 2 times the square root of 6. Simplify that. Yeah. 4 times the square root of 2 plus 16 times the square root of 6 minus 2 times the square root of 6. Is there anything we can combine? 16 square root of 6 and 2, negative 2 times the square root of 6. So 4 times the square root of 2 plus, simplify that or combine that, what would we get? 14. Do we have any questions on this so far? We're going to do one more of these and then we're going to do one of these applications and then I'll give you time to practice. So number 16. We now have 4 things. Can we simplify any of these things? What number are we doing? 8. 16. The 8, yes. To what and what? 4. 4 and 2. So this would give us 2 times the square root of 2. We would bring down that plus 4 along with everything else. And then we could simplify. Negative 3 times the square root of 6 minus 5 times the square root of 6 plus 8 times the square root of 2 plus 4 times the square root of 2. Is there anything we could combine? Do that one more time. 6 is in 6. So if we combine our 6's, what would that become? If we combine our 2's, what would that become? Not 8. So you could write it like this, where you can switch it. Both of those answers are correct. Questions on that?
4 times 4 from like the 4, 9, 6, would it be 16? Something? 16.
What? 2 fourths were you talking about?
You see how there's a 4 outside of the 96? Wouldn't it make it 16?
I don't know what problem you're on.
I'm on number 12. That's the one we're doing, right?
No. Yes, that was 16.
Wait. For number 16, what happens to the 16 2 from
16.
from the 4 and the 8? This is not like 4 and 2, and since there's like a 4 out here, and 4 times 4, so 16.
Hold on, because I think you're confusing yourself. Let's go through this and then I'll just come help you with that. Okay, so both of these are really the same thing. One is just a triangle, one is a rectangle. With perimeter, how do we find perimeter of anything? Add up all the sides. So if you're given the perimeter of a triangle, you would add up all of these, simplify them first, and then figure out what that is. Same thing for 18, but because they're talking about a rectangle, you have to remember a couple things. One, they're only giving you 2 sides, so if I were to draw a rough sketch of this, you have to remember that there are 2 other sides, so you're going to be adding this up 4 times. Or, if you were doing the perimeter equation, you could multiply both by 2 once you simplify it. No matter what you do, you have to simplify it first. Okay, so let's do that. 2 times the square root of 4 over 5. What is the highest perfect square we can divide out of 405? 400. 400 is a perfect square, but that wouldn't give you a whole answer, a whole number answer. So if you don't know, start dividing. 81 and what? So that would become 9 times the square root of 5 times this 2 out here. So 18 times the square root of 5. And then we do the same thing for the width. What is the highest perfect square we can divide out of 48? 16 and what? So that would be 4 times the square root of 3 multiplied by 9. 36. So now that we have those 2 numbers, you could either take this multiplied by 2, take this multiplied by 2 separately from the equation, put it in the equation, or add this up plus this plus this plus this. Either one. So when we multiply this, 2 times 18 would give us 36. 2 times 36 would give us 72. We can't combine these anymore because they have different radicands. So that would be our perimeter. If we actually wanted to know what that was, we could put it in our calculator, find the decimal, but that's not important. Do you have any questions on this problem? I'm going to give you specific numbers to go back and practice. I'll go back in 1 second. So number 2, number 8 on the first page. So 2 and 8. On the back, 11, 14, 15, and 17. So 2, 8, 11, 14, 15, 17. Work through those 6 in the next 10 to, I'll say 15 minutes, and then we'll go through those. It may not take that long, but we'll try. The simplified answer was 4 times the square root of 5. Number 8 was 33 times the square root of 5. What questions do we have on those two? At the end? 33 times the square root of 5. Number 11. Negative 12 times the square root of 2 minus 3 times the square root of 3.
So bad at myself because of that. I don't even understand the action.
14. 88 times the square root of 6. What questions do we have on those two?
I don't relate. I'm so bad at myself.
15 was negative 4 times the square root of 5 plus 3 times the square root of 7. 17 was 52 times the square root of 2.
Were the number 15, we're supposed to add together only 5? Subtract them.
So whenever there's just negative or negative numbers, then I plus 1.
If it was negative, it'd be negative 1. But yes. Do you have any other questions on these? Very briefly, we're going to start multiplying, but we're not going to finish it, and then we'll finish it next class. Me, personally, I feel like multiplying is easier, but I'll let you make that decision. So when we multiply the numbers out front together, so the coefficients together. Then we multiply what's underneath the radicals, so the radicands, together. We're using this product rule. That's why anytime we are multiplying or simplifying, when we have things underneath the square roots, we can combine them all, put them all underneath the same square root or cube root, whatever. We may or may not need to simplify the radical at the end. So for number 1, the numbers on the outside, we would multiply 1 and negative 3. On the inside, we would multiply 8 and 2. So on the outside, we would have negative 3. On the inside, we would have 16. Can we simplify the square root of 16? Yes. To what? 4. So in this case, we completely get rid of our radicals, and we're left with a whole number.
Is that how they're gonna be, like, all of them?
No.
That
Unfortunately not. That one just happened to work out that way. Priscilla.
So we basically ready for multiplying the funding.
Let's do number 3. Multiply what's on the outside, and then multiply what's on the inside. On the outside, what would we have? Negative 35. On the inside, what would we have? 120. Can we simplify that? It's not a perfect square, no. Make sure you guys are paying attention. Kayla, Kaden, make sure you guys are paying attention. No, this is not a perfect square, but we can take or divide out the highest perfect square that goes into this, which is what? 4. 4 and what give you 120? 30. Can we break down 30 more?
Yes.
Yes, we can, but it doesn't break down to have a perfect square. So if we broke down 30 more, we'd have 5 times 6. 6 can be broken down to 3 and 2. So we have 5 times 3 times 2. None of those are the same, so none of those would come back out. It would just stay the square root of 30. So even though it seems like it's a big number and we should simplify it more, there's nothing we can simplify it to. So we would multiply negative 35 and 2 to get what?
Negative 7.
Negative 70 times the square root of 30.
That is the most awkward.
It looks like it should be simplified more, but there's nothing else we can do with it.
And they're all like on.
I have one question.
Yes.
How would you simplify one thing that only has like it's like inside of the radical or inside the square root?
Give me an example.
Number twos.
So you would multiply 3 and 2. 6 cannot be simplified, so it would just stay negative square root of 6.
How did we get?
Multiplying negative 35 and 3. We're going to do, we'll see if we have time for 2 more of these. For number 6, now we have variables.
You say 2.
So we're going to do the same process, but then think about what happens with our variables. We will have to combine them, yes. So on the outside, we have negative 5 times 3. On the inside, we have 20x times 15x. So on the outside, we have negative 15. 20 times 15 is what? 300. And if I have x and x, if I combine those together multiplying, that would become x squared. Yes. So now that we have 300 x squared underneath the square root, we're going to simplify it. What is the highest perfect square we can divide out of 300? 100. And 3. So that would give us 10 times the square root of 3. 2 goes into 2 how many times? once, so that would be 1x that comes out. So if we rearrange all of this, we would get negative 15 times 10 times x times the cube root of 3, or negative 150x times the square root of 3.
That's the answer.
Yes. Okay, so I'm still confused on x. What do we do with the x2? That's right. It's
Put it here. 2 goes into 2 how many times? 1. So nothing left over. Okay. So as we were doing before with our variables, we cannot do that in a calculator or find a way to double check our work with that. But you could put in your calculator negative 5 times the square root of 20 times 3 times the square root of 15, and then negative 150 times the square root of 3 and see if that matches. So no one should be packing up yet, if we're not done. Do we have any other questions on that? We're going to do one more and then we'll be done. Number 10.
I love this. Today, right?
We're doing 10. Yeah.
Of course we are. Yay.
Okay. So for this, sometimes you will not just have multiplying, sometimes you'll have adding or subtracting with that. So you have to think about your order of operations. Would we add these together first or multiply these together first? Multiply. So let's multiply these two. There's nothing on the outside. So on the inside, multiplying them together, 12 times 2 would give us 24. X squared times x to the 4th. We are adding the exponents. So that would be x to the 6th. Then we would need to simplify that. What is the highest perfect square that goes into 24? 4, and then 6. So this would be 2 times the square root of 6. 2 goes into 6 how many times? 3. And I'm going to bring this down. And rearrange. So we have 7x to the 3rd times the square root of 6 plus 2x to the 3rd times the square root of 6. Now in order to combine these, they have to have the same radicand. With variables, they have to be the same variable. And they have to have the same exponent. So if all of that applies, then we can combine these. If this was x squared and this was x to the 3rd, we could not combine these. But because they are, we can. So if we were to combine these two, what would our simplified answer be? 9x to the 3rd times the square root of 6. Because at that point, you're just combining like terms. Where do you get 24?
Wait, what we added?
Hold on, because Peyton raised his hand.
Where did the exponent for 6 go? Like, how does that turn into 3?
The exponent for 6. 2 goes into 6 how many times?
Oh,
3 times. Jenna, ask your question again.
How do you get 24?
12 times 2. We're going to multiply those together. 12 times 2. You can answer your question.
Why do we only have 1 6? I thought we was
Why did you do what?
Why do we only have 1 6? I thought we was adding 6. Alright, the square root.
No. So think about if I had the square root of 6, plus 3 times the square root of 6, and now I have the times this thing. You guys can put your calculators up.